today we're going to demonstrate how a siphon works, and this is a great application if you needed to drain a large reservoir of water such as a fish tank, a hot tub, or a pool, or if you needed to get some gasoline out of your car or an old vehicle of some sort. So the first thing that we want to do is establish a full chain of water tension, and we're going to do that by submerging our long tube completely in our fluid if we have an open reservoir. However, if you had a gasoline tank, you'd have to stick one end of the tube in the tank, have one end in your mouth, suck it to make sure there were no air bubbles in the tube, and plug it with your thumb to create that water tension. So since I have an open reservoir, I'm going to stick my thumb in one end of the tube to keep the chain of water tension, making sure that the other end of the tube is still completely submerged in the water. The next thing I'm going to do is pull it so it's lower than the start of the other end of the tube, and then create a low pressure environment by pulling my thumb out and just letting the water flow. So once the water is flowing, it's really gravity that kind of does the work and keeps the water flowing. As you can see, if I were to pull the tube higher than the starting point of the other end of the tube, the water flow would stop and it's not flowing anymore. And since I've broken the chain of water tension, it's not going to start even if I put it below the other end of the tube.
So one theory to explain how a siphon works is the cohesion tension theory. And essentially what the cohesion tension theory says is that the tension between molecules and a gravitational input on the lower end of the siphon keeps the siphon going at steady state for as long as there's enough water on the higher elevation. So a great way to visualize this is having a long string of beads in a cup or a container, and I'm just going to lightly toss this out, and essentially what's going to happen is the tension between each bead is going to pull one bead after the other, the same way that the water tension between water molecules would pull one after the other and continue the siphon going. So this is how that looks. When trying to understand the mathematical basis behind why a siphon can continue at steady state without any apparent driving forces, like a pump or turbine, we can use Bernoulli's equation. So our point 1 is going to be where our water enters this part of the siphon, and point 2 is going to be where water exits. The water is moving in this flow direction. And our datum is just going to be our first water level. So over here with Bernoulli's equation, we can see that our velocities are actually going to cancel out because they're equivalent. So that's not going to have any effect on it. What is going to influence it is the pressure component at point 1 is made up of the pressure from the height of the water, the hydrostatic pressure, as well as atmospheric pressure, while the pressure component at point 2 is only made up of atmospheric pressure. So what's going to happen is that difference in pressures is going to be the driving force behind why water is being essentially pushed out of this part of the siphon and pushed into and flows into this area. And that is going to continue as long as there's a difference in water levels. However, if these water levels were to reach the same point, the siphon could not continue because there's no difference in pressures.
So one important limitation of a siphon is the maximum height between the entrance of the siphon and the apex of your tube. This can be seen through a simplification of the Bernoulli's equation. Now the reason that this maximum exists is because that there's such negative pressure inside this tube that the pressure actually reaches the vapor pressure of water. This causes the water to boil, which breaks your chain of water and therefore does not allow your siphon to flow anymore. Now if you were to solve this equation at standard atmospheric pressure for water, you would find out that the maximum height for a siphon without any other pumps or turbines would be about 10.3 meters.